I want to actually send out a congratulations to a couple applications that were just launched on Google Play while that talk was going on. So if any of you pushed the publish button on this, give yourself a round of applause. Flappy Toaster. Nobody? No one? That wasn't? We also got Floppy Dog, Flippy Shoe, Clumsy Brick, and Flappy Fowl. No, that wasn't anybody in here? Okay. All right, well, for those of you who aren't making Flappy Bird clones, or perhaps just are, here to talk about multiplayer services is Dr. Todd Kerpelman. Give him a round of applause.
Thank you. Not an actual doctor. Let's swap this out, make sure this is working. Hey, look at that. All right, we got our presentation. So thank you very much for hanging out today. We have a lot of presentations and not a lot of time to do them all. So, oh, and I should reset the timer. Look at that. Awesome. So I'm just going to get right into the presentation and tell you a little story about the Kerpelman household. So right now I am an iOS developer, or at least I do some iOS development, so I have an iPhone. And my wife has a very lovely Moto X. And right now there's a lot that we can do with each other with these phones, right? Like I can send her a text message and say, hey, I'm going to be home late tonight. There's a lot of meetings at 10 o'clock. And my wife can send me back an email. And, you know, I could send her a Snapchat. Wait for it. There we go, because I'm totally into Chinese trading vessels. And we can, you know, send each other various messages through different kind of messaging services like WhatsApp. We can even do this thing where we can communicate through real-time voice. I forget what it's called. Oh, right, making phone calls. We can do that too, right? But suppose we actually wanted to play together, play a game. Oh, sorry, you can't do that. I mean, I guess we could ask you, the small indie developer, to, you know, go ahead and spend a lot of money on like some back-end services, and then, you know, go ahead and add in all that network code to your client and deal with all the infrastructure, and then, you know, spend a whole bunch of time working on UI work where you can invite your friends and make sure they're listed in the people picker. And then add in all that code scaffolding so that your cross-platform game can then talk to the libraries that you have written on, you know, the Android and the iOS side. And then I suppose in the time that you have remaining before you ship, maybe you could work on your game. And like, really? Is that the best we can do? How do we get to a point where we think this is okay? Like, if our phones couldn't call each other, we would be taking them back to the stores and saying, this thing is broken, I want my money back. Like, why should games be any different? And I don't think they should be. And so that brings us to Google Play Game Services. And what you may or may not know about Play Game Services is that one of our core tenets is that the entire platform, or the entire experience, should be cross-platform. I think a lot of developers out there still think we are Android only, and maybe that's because we're Google, or maybe it's just the green in the logo. I think we should have gone for a nice multicolored logo. But the fact of the matter is we have had library support both for Android and from iOS, you know, when we first launched. Yeah, sorry, I wasn't quite sure legally. Anyway, and so we do love both of these platforms. And we should point out we also have a REST service available for everything, so that, you know, any device that can access the internet could access these game services, right? If in the future, one day your refrigerator's hooked up to the internet, you could unlock an achievement for eating the last of the ice cream. And so we've had library support for a lot of these cross-platform features, right? We've had cross-platform achievements and cloud save, which can be really cool if you happen to use both types of devices regularly. Yeah, I do. You know, I can play a game on my iPhone and save it to the cloud, and then continue from where I left off on an Nexus 7. And you know, that's pretty cool. It's when you see that happen, it's kind of magic. And I'm guessing for a lot of people in this room, you also have, you know, multiple brands of devices that you're using at the same time. Granted, probably among the general population, this isn't quite so common. But things do get more interesting once we bring in cross-platform leaderboards. Then, even if I am a one-brand device kind of household, I can still compare my scores with that of my friends, again, sort of no matter what kind of device they're on. And then we've had multiplayer support, and it's been a little incomplete. So we launched with support for real-time multiplayer on Android devices back when the service first launched about 10 months ago. And then we added support for turn-based asynchronous multiplayer games, again, on Android devices about 2 months ago. But something has been missing. And so what we are super excited to be launching this week is cross-platform multiplayer for both Android and iOS devices. Hooray! So Yeah. Yeah, you can clap for that. That's cool. And so, you might be asking, well, okay, this is great, but is it really worth it? This suddenly seems like extra headaches. I now have to keep like these 2 clients in sync when I push out an update. And my answer is yes. I guess it would be, otherwise I wouldn't be giving this talk, for multiple reasons. The first, honestly, it is a really cool trick. Like the first time you see a cross-platform real-time game across an iPad and a Nexus 7, it's kind of magic. You're like, how did that happen? What kind of crazy sorcery is this, right? So it is very cool, and you'll get street cred, I guess, if you can make this happen. The second thing, honestly, is I think it's the right thing to do. We've been saying, as game developers, we've been saying forever that like games are the ultimate social experience, that our ancestors, once they were able to hunt enough meat to not starve, and they were able to get loincloths and hang out in caves, the next thing they did was they played games together, right? Games are sort of the ultimate social experience. People have been doing it forever. Animals do it. It's a fantastic thing. And it seems kind of weird and broken that not everybody can play games with all of their friends because they just chose to buy a different brand of phone. So I think we need to fix this. And then, honestly, just from a technical point of view, you're going to have much better matchmaking. And I'll drill into this a little bit. If you think about a typical mobile multiplayer setup, generally speaking, you're going to have a client kind of peer-to-peer mesh network, something sort of like this, where all these devices are talking directly to each other. And what we find in these kinds of situations is the quality of your game experience is directly proportional to the number of people you have playing at any given time. So if there's a lot of people playing, you're going to have a really good multiplayer experience. By contrast, if you had a really sparse network, if you didn't have a lot of people looking to play at any point, you're going to have fewer options when it comes to matchmaking. You might find that your players, in San Francisco, their only option is going to be some player, way the heck on the other side of the world in South Africa. And no matter, how hard you try, you're not going to get a great connection time there. You can't increase the speed of light. You also might find that it takes a lot longer for your players to find somebody else to play with, right? Again, if you've got a sparse network, maybe not a lot of people are looking to play at any given moment of the day. Your players have to wait longer to find matches, and they'll get bored and leave. I think we found that your players will start to leave in significant numbers after like 12 seconds, which isn't really a lot of time. And so what if we were able to take your pool of players, right, and double it? So at this point now, we have a much richer pool of potential opponents that we can start matching up against each other. And that means, one, we can match up people who we know are going to have better internet connections, who are close to each other geographically, and two, we can match them up much faster. So you have a much better matchmaking experience happening much quicker. And so I think that's pretty good. So this was a lot of talk. Let's show a brief demo. This is Battle Pillars. This is an upcoming version of Battle Pillars from the developers HitSense. They were kind enough to start hacking with this library for us. And they already had their Android version of their game working using Play Game Services. And then, all in all, it probably took them less than a week to get the iOS version working and talking to the Android versions as well. They probably could have done a lot faster if we weren't, swapping out the library on them every week. But that's what happens when you're in early development. So let's talk a little more about the real-time multiplayer aspects. So we do set up a peer-to-peer network between different devices. A player can, of course, choose to invite their friends. But if they do decide they want to auto-match, we're fairly intelligent about who we auto-match players up against. So we've got probably, 10 months worth of machine learning data built up, where we've started to learn that not only do players in the same general geographic location tend to have better connections, but also we've learned that players in city A and players in city B, for some reason, maybe the tube on the interwebs is really big between those two cities, have really good connection speeds, but players in city A and players in city C don't connect very well. And so we've started to learn about what players will potentially play well together, simply based on sort of connection time, and we've learned that generally over the last few months. So once we're able to sort of intelligently match up people, we can get them together in a game. The devices will then connect up to each other directly through a peer-to-peer mesh network that looks a little something like this. We do allow you to choose variants and bit masks so that, if, for instance, your game had a capture the flag and a team deathmatch variant and you found that your players only wanted to match up with other people that were playing team deathmatch, we could get rid of those players that were, get rid of those players that were looking to play capture the flag and make sure that you only get matched up with other people looking to play the same type of game as you. We do a fair amount of work around NAT busting. I don't understand all the technical details myself, but generally speaking, if you find that your user is behind a firewall or is unable to connect with another device, we generally figure out a way around this, I think roughly 92% of the time. As for those other 8% of your players, if they are behind some incredibly strict firewall that simply doesn't allow them to connect to another device no matter what, we will allow them to send their game messages through Google servers, right? So they can send their messages to us, and then we can relay that on to the player they were trying to connect to. And obviously, this is much slower than connecting to another device directly, but we sort of are going on the theory that any connection is better than no connection at all. We also do support invitations, as I mentioned earlier. Suppose you want to invite specific people to play a game. Those work as well. I think as you saw in the last slide, we do send messages to Android devices using Google Cloud Messaging. But we also send Apple push notifications to users with iOS devices. You would upload your push notification certs to our server, and then we would use those to make calls to players on behalf of your application. And so what that means is, whether your application is running, whether it's running in the background, whether it's been, terminated from memory, your user will still get that notification. They can click on it. It will bring up your game with the data available in that notification payload. And you're then able to jump right into a game, sort of no matter what state that your game was in before, which is kind of nice. Messages can be sent two ways. There's reliable. This is when we absolutely want to make sure a message is received by the other player. This means that messages are guaranteed to be received. You will receive a receipt that the message was read. All these reliable messages are guaranteed to be received in the order they were sent. But of course, this tends to be a little slower. And then we have unreliable messages. This is where you say, I don't care about dropping messages or messages being received out of order. Just send this data as fast as you can to all the other players. For those of you who know about network protocols, this first one is basically XMPP, and this bottom one is UDP. Or I guess I should say it's usually UDP. Sometimes it's not. And so generally the way we see game developers use this is they will send a reliable message for sort of initial game setup and, hey, the game is over, here are the final results. And then they'll use unreliable messages for most of the other game messaging in between. And in case I didn't make it clear at the beginning, all of this is totally free. So goodbye, bag of money. I don't know why you're storing your money in a big sack like that anyway. Our whole point here is we want to make gaming better. And that means, one, making multiplayer games truly multiplayer, but that also means making sure that you can spend more time on gameplay and less time on boring stuff like network code and dealing with back-end infrastructure issues. So we've talked a little about the real-time multiplayer. Let me give you a few details about the turn-based asynchronous multiplayer aspects. Like in real-time multiplayer, we allow you to match up with people you know through invitations, or we can auto-match you with other random folks out there on the internet. We also, by the way, allow you to mix and match if you want to start a 5-player game and want to invite 2 specific people and just want to be auto-matched with 2 other random people. We allow you to do that. And I guess the big difference here is we don't care so much about ping times. These are generally games where a turn will last 24 hours, and so ping times don't really matter there. The way the system generally works is that our servers keep some information about your game. So we know some data that is associated with that particular match. We know the players who are there in the game or the players that are waiting to be invited into the game, and we know whose turn it is. We'll send that information on then to the player whose turn is supposed to be taken next. That player's game client will then take the turn, update the game data, and also determine who's supposed to go next. That information then gets sent back to our servers. We then pass that along to the next player, who then will take their turn, alter the game data, determine who the next player is, send that back to us, and so on and so forth. And I should note this example was kind of round robin, but it doesn't have to be that way. Like if we were playing a game like Risk or something and our bunny were to get eliminated from the game, our game client could know that, and we could determine, oh, okay, the next player to take their turn is actually the bear. And we would just pass that information along to them. So you can have turns going in any arbitrary order you want. Granted, most games tend to just go around the table, but again, it's completely up to you. In all of these situations, both turn-based and real-time, we provide all the UI for you. So if you don't feel like spending your time building out a, let me pick out my friend's picker and a waiting room and let me see all of the games that I have queued up and which ones are waiting for me to take my turn, I don't blame you. That's really boring stuff, and we don't want you to have to do it. On the other hand, if you have a marketing department that insists that you have a consistent brand experience throughout the blah, 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 then we do let you grab all this data directly from our service, and you can go ahead and you can create your own UI. But again, that's sort of up to you. Our goal here is that we want to make sure you spend more time on gameplay and less time on UI work. So, gosh, I wonder if we're going to be able to eliminate that last bar. Let's find out. Sorry. So I would be remiss if I didn't mention a couple of drawbacks here, because I do want to be upfront about all of this. As you know, all this game data is being generated by the clients themselves, and our server does nothing more than kind of pass that data along, from one player to the next. Like, as far as we're concerned, that's an opaque blob of data. We know nothing else about it. And this has two implications. One is that the user with a hacked game client could alter this, in a way that your game might not expect. And, of course, in this kind of situation, you just want to code defensively, right? You should always kind of look at any player-generated data with a little amount of suspicion, right? And make sure that if something looks off to you, you just reject it and, don't let it set your player on fire. This also, by the way, means that you don't have the ability to perform any server-side kind of logic or, running batch calls in the background via a cron job or analytics or anything like that. Again, all the server is really just on your client, and our servers just pass it around. And I'll be honest, this is generally a concern you only need to have once your game gets more popular or your company gets larger. And when you do get to this point, it's fairly easy to make the transition from keeping your game data on our clients to keeping game data on, say, servers that you're running yourself, or your own cloud-based platform that you're using, something like App Engine, say. Basically, you would keep the entire system you have before. The only difference is that instead of your game data being your actual game data, the game data would be a link to where your real game data lives on your server or on your App Engine instance or whatever. This, by the way, kind of gives you the best of both worlds, right? You can still keep all of our UI if you don't feel like building out our UI. You can still take advantage of our notification system to notify Android and iOS devices. And most importantly, your players' incoming games will still show up on the Play Games app on Android devices if they're looking at that. But this also then means that you get your data on your servers, and you can perform server-side validation, you can perform batch processing in the background, you can analyze all of this data. So this is kind of nice. That being said, I've talked to lots of game developers, even larger ones. I don't think I've talked to a single game developer that wasn't strapped for server engineering resources. So if you're just starting out, and you're trying to prove out your minimum viable product, or what minimum viable product means, and you're sort of at this early iteration stage, I would encourage you to stick with the client-only version if you can. And once you actually have gotten to the point where you say, yes, I think I have an actual fun game, then go ahead and transition to this kind of server solution. But that's just my recommendation. So let's talk a little bit about some implementation strategies. Right now we have a Java library available on Android devices for those of you who are writing games in Java. And on the iOS side, we have an Objective-C library for those of you who are writing games in Objective-C. But the truth is, not a lot of people make games this way. We did, or we tried it. This is a game we built called Nostalgic Racer, and here's a quick little demo of it. And I'll be honest, this was a terrible idea. While this gameplay actually works, if you watch, you can see the cars' position relative to each other is correct. Everything else looks off, right? Like the color palette is off, the car geometry is off. Thanks to an off-by-one error, the actual track is off by a little bit. And it turns out the iPad accelerates faster than the Android version. So I usually won any game that we played. And so this was obviously had a lot of issues, and it also meant that any type of change we made had to be made twice, right? Like once on the Java code base and once the Objective-C code base. And so my guess is very few of you are actually building cross-platform games this way, or probably aren't anymore if you've tried it once. And so for a lot of you, that means using some type of game engine or middleware. I know that one of the more common ones out there has been Unity. I believe they're having a developer day today, but stay here. This is going to be better. So basically, you write your Unity project in C# or JavaScript if you hate yourself. And it basically, some JavaScript engineers out here, I see. And it basically generates a mono interpreter, running in C++. And then there's some work involved in writing some scaffolding to connect this generated code to the libraries on the two various platforms. And there are sort of various ways to handle this part. Some of you have done it yourself. There are some plugins out there for Unity that do this. And we have written our own Unity plugin that is available on our GitHub page. It is open source. It is freely available for you to use, download, modify, alter to your heart's content. And we have had support for achievements, cloud save, and leaderboards up until this point. And this week, we are going to be adding support for cross-platform and real-time multiplayer on Android and iOS devices. So we're super happy about that. And if any of you are Unity engineers, I think this is probably the easiest way for you to get a multiplayer game going. So definitely check it out if you're at all interested. So here's an example of a game we made using Unity. We took another racing game and decided to take all of the excitement of car racing out and replace it with math. So here you're answering math questions to make your car go faster. And I know this is super exciting, but I'm guessing you could do even better. But the one thing I do want you to notice is that this does now look like the same game running on two different devices, right? The aspect ratio is a little different, but we now actually have the same game logic, the same game behavior running on both of these devices. And we didn't have to make any code changes to the C# project to make this run cross-platform. There's no, if application.platform.whatever equals iOS do this, right? It's the same code base, which is pretty nice. So implementing this is pretty straightforward. I'm not going to go over it now because we have a README file that you should read. But basically the steps are you would import this custom package like you would any other custom package. We have a couple of dialogues for you to fill out. We have one question for you to answer on Android and 3 questions for you to answer on iOS. And then we kind of do the rest of the work for you. The calls themselves, they're just C# calls. We went with the strategy that we want to make the common calls as simple as possible and sort of the more obscure cases possible. So you'll see here that, for instance, this call here with 4 parameters would bring up the entire, hey, let me invite some folks to a game, and then return that game to my listener. We do implement the iSocial interface where appropriate, but in places where we do more than what's in the iSocial interface, we have our own Play Games platform that you would call. And so I encourage you to check it out. But what about those of you who don't use game engines or have written your own? Well, most likely you've written this in C++, and then you've had to do this somewhat annoying busy work where you add in your thin layer of abstraction so that you port your C++ calls through JNI to the Java library on Android, and you do something else on the iOS side of things. And here's an extra bit of fun. On Android, for multiplayer, we then make an extra bit of calls back out to C++ for some of the multiplayer stuff. And so this is horrible. And we thought, gee, this is kind of a pain. And so maybe if we're developing a cross-platform service, we should have a cross-platform library. And yeah, you can clap for that. We got, all right. C++ developers in the house. Yeah. That's a pointer right there. So anyway, sorry. Yeah, so we're releasing this week a C++ library that you can use for your own libraries that you have written. And I should point out this isn't just a thin client that supports REST calls. I think there's a bunch already out there that do something similar. We are adding in all of the nice support features that our Java and our Objective-C libraries already have. And so this includes things like OAuth 2 management. If your OAuth token expires, we can go ahead and get a new one in the background without your user ever noting that anything was wrong. It means network retries. So if your user has earned an achievement on an airplane and she has her phone in airplane mode, we will store that call and keep it until your user gets off the airplane, turns off airplane mode, and then we will retry that call to make sure that she gets that achievement she's earned. It doesn't get dropped, which is really nice. We have some intelligent local caching. If you submit a score to a leaderboard that's not as good as one you submitted 5 minutes ago, we won't make that call out to the server. That will save your user a little bit of data and also a little bit of battery life, which is always nice. We have UI widgets so that, again, you don't have to spend your time building out let's show all of the achievements with icons depending on whether or not the user has unlocked them or not. Again, you can leave that UI work to us. And we have a much better threading model on Android. So all of our methods are non-blocking asynchronous calls that can be called on any thread. If you're an Android engineer, this is very exciting. If you're not, write that down and go back to your office and tell your Android engineer, and he or she will give you a big hug. Should point out this is version 1.0, so the library itself is production ready, although in terms of features right now, we have support for sign-in, leaderboards, and achievements. That's what we currently have. I am not supposed to commit to future features, but clearly our goal here is to have all features available on all devices. So hopefully you can kind of see where we're going with this. And all of this means that you can spend less time on code scaffolding work and more time on your gameplay. We did it. We got rid of that last bar. That's so great. Let's review. Here are the big things that we talked about today. Real-time multiplayer on iOS and Android, turn-based asynchronous multiplayer that you can play between iOS and Android devices, a full-featured Unity plugin, and a C++ library that you can start hacking with, I think, like today. Yeah. And so I think with that, all of the tools and all the power are sort of in your hands now. We want to play games in the Kerpelman household, and there are millions of households and schoolyards and conferences just like this one, all full of people looking to do one thing, and that's play together. Macs and PCs have played together for years, and even then, while most of the burden has been on the developer to add this, I think it's been a huge benefit to both of those platforms, as well as to players and those developers, right? And we have an even bigger opportunity here. Like, if all of the reports are right, the number of smartphones in the world is going to pass the number of PCs out there in the world. And so many of these people are gamers, right? So many. And so we have this opportunity to bring the world together in gaming experiences that have never been seen before in the history of civilization, like ever. And I think that's pretty exciting. Hopefully you do too. So thank you very much. Go ahead and follow me on G+ or Twitter. Yeah.